this video, we are going to talk about how we can use ones complement and two's complement. So let's start with ones complement. In ones complement, it's really straightforward. Okay, so it has 8 bits. Okay, normally ones complement also has 8 bits representation. So we have 8 bits representation. What happens is if a number is positive, okay, if a number is positive, you just write down the number by using the 8 bits, okay, and that's it. That's all you're going to do. Okay, that's all you're going to do. So since we have 8 bits, okay, so there are 8 bits. Yeah, there are 8 bits. The thing is, the range that you can represent by using ones complement in positive is from 0 to 127. Okay, we can't use the first bit. Okay, the first bit is not for use. Okay, it's always 0 for positive numbers. Okay, so you can represent from 0 to 127. You just change the number, the decimal number, to its binary form, and you'll write down you fill out the 7 bits like you did in sign magnitude. I'll put the link in the description. Okay, so you can only represent from 0 to 127, and the special part is that the first bit is not used for representation of the number. Okay, so that's for positive numbers. Okay, so for negative numbers, what happens is you will just inverse. Okay, you'll just inverse the number. So what am I saying by inversing a binary digit? Well, what you have to do is, let's say we have 0. The inverse of 0 in bit is, the inverse is 1. And for 1, the inverse is 0. Okay, so let's say you have a number like 0, 1, 0, 1, 1, 0, 1, 1. Well, the inverse will be 1, 0, 1, 0, 0, 1, 0, 0. That is what we call the inverse of a given number. Okay, so for the ones complement, when you're representing the negative number, first of all, you'll find the positive number. Let's say you're finding the negative 67. Well, first of all, you'll find the positive number 67, and then you'll write it in the ones complement form. Then you will write down the inverse of that. Okay, so since it's negative, you will just do the inverse function. Okay, so when I'm speaking about that, you may think you are not able to understand what I'm trying to say. So let's practice some questions so that you will be able to understand. Okay, so only 2 rules. If it's a positive, the first digit is 0. Okay, the first digit is 0, and you have to write down the other 7 bits for representing the number. If it's negative, first of all, you write the positive number, then you'll just inverse it. Okay, so let's say we have plus 12. Okay, let's say we have plus 12. Since this is a positive number, the first bit will be 0, like in sign magnitude. You just have to put 0. And we know 12 is equals to 8, 12, 0, 0. 8, 12, 2, no 1. So 1, 1, 0, 0. Since we have to add 7 bits, we will just add 3 zeros in front of this 4 bits. So it will be 0, 0, 0, 0, 1, 1, 0, 0. This is the ones complement form of positive 12. Okay, so what about negative 12? Okay, so as I said, what you have to do is you will just find the magnitude. Okay, the 12, which is positive 12. So the number will look like this in ones complement. Since it's a negative number, what you have to do is you have to inverse this number. So it will be 1, 1, 1, 1, 0, 0, 1, 1. Okay, and let's do a bigger one. Okay, let's do a bigger one. Something like 70. Well, 70, positive 70 is a positive number. So the first bit will be 0. And for 70, we need a 64. And then we need 6. So no 32, no 16, no 8. Yes to 4, yes to 2, no 1. So it will be 1, 0, 0, 1, 0, 0, 0, 1, 1, 0. So 1, 0, 0, 0, 1, 1, 0. So this is the positive 70. Okay, so what if you have to write down the negative 70? Well, you'll just find the inverse. So it will be 1, 0, 1, 1, 1, 0, 0, 1. That is changing the zeros to 1 and ones to 0. That's what we call inverse. Okay, so this is the method we call ones complement. Okay, let's do another positive number, plus 120. Well, it will be from 0. So the first bit will be 0 since it's a positive number. And 120 can be achieved by using 64, 96, 112, Here 120. Then we can have 40. I mean 30. So the positive 120 is 1, 1, 1, 1, 0, 0, 0. Well, now we are going to negative 120. You have to find the inverse of this. Since it's one's complement, you just have to find the inverse of it. So it will be 1, 0, 0, 0, 0, 1, 1, 1. That's it. Pretty straightforward. There are some problems with this one's complement method also. The thing is, there are also two zeros, like in sign magnitude. Okay, so let's say you have positive 0. Okay, so positive 0 will look like 0, and then you will just put 7 zeros behind that. Okay, so what happens is, if you inverse all these things, what will you get? What will you get? You'll get 1, 1, 1, 1, 1, 1, 1, 1. Okay, it is just negative 0. So this representation also has a small problem with it. That's why we don't use it in normal day-to-day applications. Okay, that's why we use two's complement. Before we go to two's complement, yeah, now only I realized that I didn't teach you to how you can convert from one's complement to the decimal number. So we'll just learn about two's complement in a separate video, maybe tomorrow. But now let's focus on only one's complement. So how can you convert from one's complement representation to the decimal number? So if you have something like 0, 0, 1, 0, 0, 0, 1, 1. Well, there are 8 bits, and the first bit is 0, which means that's a positive number. So what you have to do is you just have to go through these numbers and write down the value. So it will be 1, 2, 4, 8, 16, 32. So it will be 32, 34, 35. Okay, it will be equals to positive 35. If you don't understand what I'm doing, you can just watch the video I have given in the description on how you can convert from binary to decimal. So this will be positive 35. Okay, so let's say we have something like 0, 1, 0, 1, 0, 1, 0, 1. Yeah, possible. Since the first digit is 0, it's a positive number. And we have 1, 0, 1, 0, 1, 0, and 1. So it will be 1, 2, so 5, 21, and 85. 64, 80, 84, 85. Okay. So let's say you have a number like 1, 0, 1, 1, 0, 1, 0. What can we do? Well, here the first number is negative. Here the first, not number, first digit is negative. The most significant digit is positive. I mean, number 1. So this is a negative number. That's what this means. Okay, if it's 0, it's positive. If it's 1, it's negative. Cool. So how can you find the real number? Well, we know since this is a negative number, okay, since we know this is a negative number, what we can do is we can apply one's complement to again. Okay, so the one's complement of this number will look like 0, 1, 0, 0, 1, 0, 1, 0. This is the positive version. This is the positive version of this negative number. If you can't understand this, let's say this value is equals to x, well then this value is equals to negative x. That's all. So you have to find this number to find this number. That's all. So what is x here? Well, this is 64. So 64, 72, and 74. So what will be this number? This is the number will be negative 74. Since you have one only, you were able to find out that this is actually a negative number represented in one's complement form. Okay, so that's why I said when I started the lesson, even though we use 8 bits, okay, even though we have space for 8 bits, the number of bits that are used for actual representation of the magnitude of the number given is 7 bits, which means the highest number that you can represent is 127. The minimal number you can represent is actually minus 127. Okay, that's how it works. Okay, and the first bit is for the sign. So you may think like, why would we do that? We have sign magnitude method. Well, one's complement has its own merits also. So that's why we use, you know, the we use the one's complement method. If you want some examples, I think I might help you with that. So it's like it's a straightforward concept. So it has a simple design in hardware, and when you compare it with the sign magnitude, this is pretty easy. Okay? When you compare with sign magnitude method, this is pretty easy. So we use it, but it's not widely used because we have two's complement, a better way of doing it. Okay? So I'll see you in the next video with a new topic, which is two's complement. So stay tuned.
Thanks for watching the 14th video in our system series. If you found this tutorial on onescomplement representation helpful, don't forget to like, share, and subscribe for more lessons. Hit the bell icon to stay updated with our latest videos. Check out the full playlist to master number systems and follow us on Instagram. I'll see you in the next video. Until then, keep learning and stay curious. Bye bye.